We've just looked at how to do a two-sample t-test using this data set that I built here. Let's then think about if we needed to refine the tails of this t-test. Let's think if I change these samples, maybe I stick with my example of weight gain in fish in a feed trial, for example, and I can call this then sample 1, I'm going to call the high protein diet, and sample 2 I'll call a low protein diet. And I'm measuring then the weight gain, and without boring you with the details, I'd expect the fish on the high protein diet to have gained more weight, significantly more weight, than the fish on the low protein diet. So I want to do a t-test, but I'm expecting there in my alternative hypothesis for there to be a direction of the significant difference. Okay, so this is my output as we had from the one sample t-test that we did previously. And I've still got the same null hypothesis. mu1 minus mu2 equals 0. Mu is just the sample mean, is the symbol for the sample mean. So the sample mean of sample 1 and the sample mean of sample 2, if I minus one away from the other, I'm going to get something that's not statistically significantly different from 0. My alternative hypothesis at the moment is that I am going to get something statistically significantly different from 0. It could be larger than 0 because mu2 is significantly less than mu1. It could be that that difference is less than 0 because mu2 is significantly greater than mu1. So we can get an idea how we can run that t-test as before, but we can refine our alternative hypothesis to look to see if there's any, if we're postulating a direction of the significant difference. This is important because if I've made a high protein diet for fish, I want to know if it's led to a significant increase in their weight gain. If it's led to a significant decrease, then clearly I'm not interested. So I've just taken that lower tail and got rid of it. That lower 2.5% of the distribution I've taken away, and I've now got all my 5% of difference up in the upper tail. So I remember we've already done our normality checks, because in order to do the two sample t-test I need both sample 1 and sample 2 to be both have a distribution that's not significantly different from the normal. And we already know that there is no significant difference in the two variances. Watch the previous video on how to do a t-test if you haven't seen this bit, and it'll go through all this. So I just can now go and do my t-test, but I want to refine it to be one-tailed. So back here to two sample t. As before, sample 1, in fact I'm going to need to change that because I've changed their names, so I've got to put those two in there. In my options, I assume equal variances, and look, here is how I can refine my alternative hypothesis. So at the moment, my alternative hypothesis is set, look, that mu1 minus mu2 equals 0. Now I want to see if there is a significantly greater weight gain in the fish on the high protein diet than on the low protein diet. I'm not interested if there is a significantly less weight gain. I'm only interested in showing that this higher protein has given a significant increase in the weight. To say that my high protein food gave a significant decrease, significantly less weight gain, would be of no interest to anybody who works in fish farming. We want to be showing that more protein gives us more growth, really crudely speaking. So it's all about refining this alternative hypothesis. So I think sample 1 is going to have a higher mean than sample 2. So my hypothesized difference of nulls of 0, I'm expecting something greater than that hypothesized difference, because I think sample mu2 is going to be a smaller mean than mu1. Okay? If it was the other way around, I'd just choose this. The difference is less than the hypothesized difference. So there we go. I've now refined my tail in my t-test. So I'm going to see what the result comes out like, and we can see my p-value has gone down a little bit. Before we had, with a two-tailed alternative hypothesis, the p-value was 0.022. With a one-tailed alternative hypothesis, it's now 0.011. So because on my graph, remember on my interval plot here, if I get rid of those, put these two back in, we can see that the mean is higher. We know it's significantly higher, and I would annotate on that p-value is in fact 0.011 rather than the 0.022 that we had with the two-tailed test. Now I need to be very careful when I'm using a one-tailed test. What I can't do is start fiddling with the tails to try and get the lowest p-value I can find. That's really naughty. Here I've got a situation where I'm only interested in the fish having a greater weight gain because they're on a high protein diet. And if that weight gain was lower, I just wouldn't be interested, and I would get a p-value that was really high. And it could be because those means weren't significantly different from each other, or it could be because in fact the high protein food was giving me less weight gain than the low protein food. I'm being very crude with my example here, but because I'm only interested in the significant increase in the weight gain of sample 1 over sample 2, that's why I've put the tail on that particular side.